Thanks, Pete. Thanks, everybody, for welcoming me here. I don't want to disappoint you, but I think I'll go very down to earth to really what is PRACE, what is its achievements, and I'll touch briefly on some more policy-oriented areas. But basically, my point to be here is really to share with all my ICT infrastructure colleagues and members of funding agencies where we are with PRACE and what is on the making for the future. Right. So I had actually prepared this presentation to suit an audience that would be not so familiar with the gigs and the bytes and all these issues that I think all of you are aware of. So I'm pretty sure that all of you know what is a T0, a petaflop machine, a supercomputer, a high-performance computing system. But if you do not, just let me give you a few images that probably capture the idea. So imagine something really big. Imagine a tower of 100,000 of today's fastest laptops with a height of 2.4 kilometers. Imagine something unbelievable. Imagine that you can calculate in 1 second the equivalent to 2 days of non-stopping computation by every human being in this planet at 1 calculation per second. This is rather impressive. Imagine also what is a number of 15 zeros. If it was in your bank account, it will mean that you are a millionfold billionaire. But you have something much greater within you than all of this. You have your human brain. This is something that not every supercomputer in the world has ever been able to make. But still, they are very impressive. They are able to do all of this and much more because of the intelligence that stays with your human brain. So this is a bit what I'm going to tell you today, is the capacity of the European scientists to exploit in a very efficient and planned way the capacity of computing that we have available at the moment, which is of 1 multiplied by 10 to the power of 15 floating point operations per second. This was the target actually when PRACE was set up. At that point in time, there were not many systems in Europe of this capability. And PRACE was set up to really get this thing online. Now we have 5 of them. So you can multiply 5 by all these zeros, and you get to understand what is available to the researchers at this point in time. What is PRACE then? Our mission is to, first of all, develop and provision a persistent European research infrastructure on HPC, to coordinate the ecosystem of HPC resources in Europe such that investments at the national and regional levels are coupled with the investments at a very, very top level so that we get to the researchers the computing capacity that is suitable to their needs. And we want to rationalize the access to the HPC infrastructure. Actually, this is the part that we are doing right now, right? We, as you have seen in our website, we have calls for proposals often available, and scientists are getting to know us via this process. But in fact, the real aim of PRACE is to deliver the best systems to the best science. And this is in a worldwide basis. That is, any researcher in the world that has a proposal and needs to execute computational effort of the range of what is called a grand challenge can apply for cycles in these machines and be awarded the most adequate systems to perform these cycles. And we have an open R&D model that allows researchers from academia and from private companies to really use the machines, provided that at the end of their allocation, they commit to publish openly, publicly, the results of the simulations. The second part is not in red because it's still being worked out, okay? As you can imagine, this is where the issues are very, very complex because you have different funding agencies, you have different bodies that administrate the funding for all of these systems, and we are really working out. We hope that by the end of this year we'll be able to already unveil really how all this tissue of gluing all the systems together will act, so that we really can say that in PRACE we are also tackling the second part of our mission. Who are we? Well, I've been told not to move too much, but I think just by the different colors I'll be able to tell you what these things mean. So we have at the left-hand side the committees that recommend to PRACE the policy to apply in terms of scientific access, the access of science to the computers. This is the Scientific Steering Committee. And below it, we have the Access Committee, which is the committee that actually runs the ranking of the proposals on our access calls. And then we have the governance. We have a council of now 24 member states that actually define the strategy for the research infrastructure, and the board of directors, of which I'm the chair at the moment. The timeline is just to give you an idea of where we are. So you can see down below where there's the little icon of PRACE on the 23rd of April 2010, to tell you how far we've been into this process of creating an infrastructure like this. The infrastructure like this is not created in 2 years. The results I'm here telling you are the result of really the work of 2 years, but there was a lot of work done before that. There was a lot of work to promote its listing on the S3. There was a lot of work to create the MOU between the PRACE members to make sure that at least the thing was geared up and people would be understanding a bit how this would operate in terms of business and operational models. Then we had all the other phases that have been framed by the Commission support, and I'll tell you a bit more about how this was important for us, and that constituted the preparatory phase, at the end of which we created the association. In Brussels, by the way, so we are a Belgian association. And by the way as well, Belgium is still not one of our members. So if I may say so, it's about time that it comes. Yes, I think by the end of this year, this will be the case. So we are about to become 26 members, and Belgium is definitely one of these two that are coming up, hopefully by the end of this year. But we have members from really many, many other European countries and associated countries to the framework program. So we're really getting to be that mass that can tackle the issue in quite a persistent way. Towards 2020, what do we want to do? The next frontier is the exascale. So it's the 10 to the power of 18 floating point operations per second frontier. And this frontier is really where Europe has to prove its value. Okay, so PRACE is there for that. With our scientists, with our computational expertise, we want to make sure that towards 2020 we'll definitely be somewhere with the exascale. We're already getting to the tens of the petaflops, and the exascale is really at the doorstep. The challenge is also to partner with European industrial users to make sure that all this performance that is there will be leveraged for the sake of them to have a feeling of really what is the capability that they have at hand. So as PRACE is a publicly funded research, we cannot afford to serve industry in terms of computation on demand. But what we can do is with some sort of prototyping and demo projects, which is actually happening already, to make sure that the industrial users understand what is the potentiality of the systems for the sake of bringing to market new solutions with more accurate results in terms of their performances and capabilities, and bring this then to their own budgeting lines for either acquiring the suitable resources or come to us again for more information on how to carry on further. And of course, very, very important, we need to make sure that we consolidate the expertise in applications. This is where the so broadly thought of ideas on creation of centers of excellence really play a role. We have a very, very good expertise in Europe in terms of software, system software, application software, and we need to make sure that we can really use this for the benefit of applications that are to be used both by our scientific community and also the industrial community. Open questions. So as you can imagine, none of these things happen without some hurdles, and the next things for PRACE, at least not specifically in the terms of the Horizon 2020, but more in terms of negotiations between the different members, is how to make sure that core partners like the hosting partners, and these are the partners that really put in the machines, and as you can imagine, on an open science model, it means that scientists from all over the world can use your national machine. And this is not something that you can sell off in a very easy way. Okay, so questions of juste retour start to become in the agenda, and this would just kill completely the possibility for users to use the system just based on scientific excellence, which is the case now. So we need to overcome this into a model that would allow these countries to continue providing resources, but having some sort of added value in really being in PRACE rather than just providing resources to their national users. The role of DC in this endeavors is very important. Why? Because we could move on without the framework program support. We've been having all these implementation phase and preparatory phase projects, but we have very, very small countries that are only now defining an HPC policy. So in order to move with them, we really count on having some support, some significant support from the framework program and in the context of Horizon 2020 to make sure that what I call peripheral countries, in order not to be offensive to anybody in the room, but you can imagine which ones might this be, are able to continue being in PRACE and continue offering their expertise and their know-how for the benefit of the whole. So this is what I mean with the catalyst effect of VC support. We've seen that countries that had national systems, even though these systems are now the so-called hosting systems, they have never been to the top 500 in the last decade. And now, thanks to PRACE, some of these systems are ranked in terms of the top 10 in the world. So even for the hosting, this network of collaboration between the centers has been proved successful to really justify to their funding agencies that the money that they are putting in really makes sense, because it starts to give them visibility. The best scientists come to use their machines. They can really market their services in the best way, and this is profit for them as well. I'm not saying it's enough, but it's already something. Just to satisfy your curiosity, I think I won't have much more time, but I'll just walk you through the calls that we have at the moment. So we have a preparatory call that lasts for about 2 to 6 months. It's an open call. You can apply anytime. We have cutoffs every 3 months. And this allows you to then come to what we call the standard call, which is the project access call that opens twice a year. So if you are not awarded in the first go, you can retry after 6 months. I know it's far from ideal, but that's what is available at the moment. So this is the project access, and the award is granted for 1 year. So they can use the machine for that amount of cycles for a full year. And the very, very new flavor in our calls is the multi-year access. So we are trying something that allows scientists to use the machines even for more than 1 year if there is really a justification for this. It's a test call, and we really hope that we'll be able to carry out with this one as well in the future. All our access is based on peer review. This slide, I'm not going to go into detail with it. I think it's quite clear, and you have it also in your printed material. But all our access is based on peer review. The preparatory phase does not contain a scientific review, so it's just assessed on a technical basis and awarded based on availability of resources. And the project access has both the scientific and the technical evaluations, with a possibility for a comeback after each of these. So that means that if you have done, or if the scientist has done a pitfall and it was not clear something to the researchers, they can still clarify at the end of the process, which I think is very helpful, because this allows then at the ranking stage to really have a very, very good idea about the proposal and what is in stake. We have awarded in 2 years 3 billion core hours. This is an impressive number. I think the InSight program is able to get to the 2 billion per year, but we are reaching already a 3 billion for the first 2 years, which means we are not still in full speed. The machines that are promised are almost all there except one, but this one will also come at the end of this year. And we are already giving 3 billion core hours, and we have not even finished 2010. So 2012. So since I think it's a pretty much a good track record for such a young research infrastructure as PRACE. The traditional areas that all of you or the ones that are aware of HPC know these are the areas that really come mostly to use these resources, but it's true that there's still work to be done to bring some other areas that will also need the resources, especially this quest for the multidisciplinary, which is like one of these very, very utopic terms, because a researcher, when it publishes, is in a chemistry journal or in a physics journal or in a biology journal. It does not publish on a physics, biology, chemistry. So we really need to overcome this idea of the multidisciplinary in terms of even the scientific practice, and this is where the scientific steering committee can really help to make sure that we don't work on these silos, and a bit of this multidisciplinary research can really come through. Now, I have some slides, but I'm not going to go in depth in them for the sake of not hurting the researcher who has really performed this brilliant work. But it's just to tell you the sort of things that have up to now run in our systems, and that can be so powerful in terms of the research the research results that come out of it. So this is an example of research on turbulence in the field of aeronautics by Professor Javier Jimenez that works for University Technical of Madrid. And this is an interesting example because this research is also funded by the European Research Council under Project Multiflow. So we are already leveraging from consortia that has been given grants at the context of the European Research Council to come to us being granted resources. The excellence is there. They have not been granted because they are an ERC. They have been granted because of their research excellence and are using our machines. And these allocations, just to give you an idea, are the order of 30 million core hours per year. A very interesting example as well is the issues that Dominic Marks and Jan Grant from just to make sure I don't say any bad, from Ruhr University Bochum in Germany, that work on theoretical chemistry and that is studying a very interesting effect on tunneling regarding the mechanism of enzymes to really leverage chemical processes. And of course, the very dear example of fusion energy by Professor Luis Silva from Instituto Superior Técnico in Portugal, that pairs with people from the US, UCLA Labs, and Rutherford Appleton Labs in the UK to come up with an idea of how lasers can influence plasma changes in fusion. So as you can imagine, this is a very, very, very important field. I think if they are successful, the way to the Nobel Prize is there for them. I really hope they do, because if they don't, the expectations are so high that they will really have to do a great job. So this is the sort of users that we have and that we really need to appreciate in terms of the work they do. And finally, the work of Federico Toschi on the simulation of how blood flows in your body. As you can imagine, this is a field where visualization really plays a big role, where mathematics to model all these cells are very, very important, and therefore we really praise this idea of these teams that work together with mathematics and in their specific field to really come up with these very important simulations. So do you remember how many zeros a petaflop per second has? I hope you've been attentive. Thank you.